Welcome back to Jackson Square. Today we are moving on to Chapter 8, which is multi-representations. And we're looking at TEK 6.6c, which says, I can represent a given situation using verbal descriptions, tables, graphs, and equations in the form of y equals k times x or y equals x plus b. We're also looking at TEK 6.64 that says I can compare two rules verbally, numerically, graphically, and symbolically in the form of y equals ax or y equals x plus a in order to differentiate between additive and multiplicative relationships. We're also looking at 6.6a, which says I can identify independent and dependent quantities from tables and graphs. So most of these TEKs that we're going to be covering all are kind of encompassed into each other. They're all wrapped up in. So we are starting with linear equations, okay? A linear equation is an equation whose solutions are ordered pairs that form a straight line on a coordinate grid. So we're just going to break this down. So a linear equation is an equation whose solutions are ordered pair. We know an ordered pair is x comma y. That forms a straight line on a coordinate plane. So we know what a straight line on a coordinate plane looks like, and we know what an ordered pair is. So we're going to start by talking about proportional relationships, okay? Proportional. When two quantities have the same ratio, they're proportional. A proportional relationship always has a straight line. They will always go through the origin. A proportional relationship will always go through the origin, and we know the origin is 0, 0. Okay? So things that we'll see in a table that always have the same ratio, 2 to 3, 2 to 3, 2 to 3. Even if it's been scaled up or scaled down, it's the same ratio. On a graph, it's always going to have a straight line, and it's going to always go through the origin. Okay? So those are things about proportional relationships. Let's talk about independent and dependent. Independent influences the change of the dependent variable. Okay? Independent is always your x. Dependent is always our y. So when we're talking about a coordinate ordered pair, the x is our independent and our y is our dependent. Okay? So the independent is always first. The dependent again is that y. And I like to think of these as like cause and effect. The independent is the cause. Because this happened, the dependent. Something happens to the dependent because of what happened, what the independent did. Okay? Independent variable is always your x. Dependent is always your y. And I call this the effect. It says the dependent relies on an independent. So right about now is perfect because right now is tax time. And during tax time, people always want a dependent, right? Children are dependent on their parents because the parents give you a roof over your head, food on your table, clothes on your back. Parents can stand alone. Adults, a parent, I could not have children and I could be quite all right. But a child cannot stand alone without an adult. You need somebody to feed you, to clothe you, to change your diapers, to teach you how to walk, teach you how to ride a bike. So you are a dependent, okay? You depend on them. And the dependent variable relies on an independent variable. Okay, remember Boosie had the song Independent. Do you know what that means, man? Right? Because she had her own house. She had her own car. She was independent. You're not independent. I know you think you are, but you're not. Okay? So remember, the dependent, something happens to the dependent based on the independent. So you are affected as a dependent if something happens to your parents. If they lose the job, you may have to move. You may have to move schools. You may not be able to get the new fancy stuff. You may not be able to get the latest Jordans. Those things you depend on your parents. Okay? So that's independent and dependent. Let's look at the equation part. So in the equation for a proportional relationship, it's going to be in the form y equals k times x, okay? Y is our dependent. What this value is depends on what's happening to the x. Y is also called our output. It can be called our range. Okay, so I'm going to give you guys all the names as you guys go up the scale and go 6th grade, 7th grade, 8th grade. The names will change, but it's still the same. Okay, K is our constant. I'm going to spell it with a K just so you remember. It's our constant. Okay, it's also called the constant of proportionality. It can be called the unit rate, right? That's familiar. When you get older, it's going to be called the slope. Now, does that letter always have to be K? It does not have to be K, people. Do not be stuck on the K. It can be an A, it can be a C, it can be a B, it can be a whatever. It doesn't have to be a K. It can be any letter. So I'm just going to write this note. Can be any letter. Okay? Because when you go to a certain grade, it's going to be A. Sometimes it'll be K. So it will not, when you get to a 7th grade, it'll be a M. So it's still a constant, even though the letter is different, okay? Our X. X is our independent. It's the one that can stand alone, okay? It is our input, and it is also called our domain as we get older. Okay? This is called a multiplicative relationship. Multiplicative. Now, don't let the name fool you. Just because it has multiplicative in it doesn't mean it's only multiplication. Multiplicative relationships use multiplication or division to compare the independent and dependent quantities, okay? Multiplication or division. So if it's multiplication or division, it's going to be proportional. If they're multiplying every time by the same number or dividing, it's proportional. K can also equal to the Y, the dependent divided by the independent, to give you the constant of proportionality. And that's more of our 7th grade skill that we need to know, that if we take the Y, the dependent, and divide it by the independent, we can get our constant. Okay? Let's look at my table. So you're going to learn how you can take the equation, the situation, the table, and the graph, and all of these things connect, how you can use one to get the other once you get really good with this, okay? So in our table, we want to talk about, it says number of hours, and then it says 60x, and it says number of miles. So I'm going to break down all these different components for us. So first of all, on your left side, this is always going to be your input or your independent, okay? And on your right side is always going to be your output or your dependent. And we want to remember our independent is our X and our dependent is our Y. So this is where my X value is going to be. See my X, and this is where my Y value is going to be. This little column in the middle is my process column. This is where I'm doing my work. Okay, I'm putting in my work. Here, in this situation, 60 is my K. That's my constant. So every single time it's telling me I'm going to multiply my X value times 60. That is not going to change, okay? It's not going to change every single time. So here I'm going to say 60 times 0. That's my X. 60 times 0 is 0. That gives me my Y. Remember, my Y depends on my X, my independent. Here I'm going to say 60 times 2. So 60 times 2 will give me 120. Here, I'm going to go 60 times 4. 60 times 4 will give me 240. What if I did 1? Okay. If I did 60 times 1, that would give me 60. So there are a few things I want to point out about this. First of all, if we made these into order pairs, this would be 0, 0. This will be 2, 120. So if I made these into my ordered pairs, like I have listed, this right here, this is the origin, y'all. This is showing me that there's a point on that line, because remember, this is a linear equation. It's going to make a straight line. There's a point on that line that's going through the origin. Hey, that's one of the requirements of being proportional. We'll always go through the origin. So we know, looking at this chart, if you see 0x, 0y, that it's going through the origin and it's proportional. So I'm trying to make those connections for you, okay? We know it's going through the origin. Right here, where I see 160, that 1, guess what that 1 is telling me? That's telling me, dude, that's my unit rate. That's my unit rate. When x is 1, y is 60. That's my unit rate, which is also called my constant, okay? So if you're looking at the table and you see 1 something, that's your unit rate. If you see 0, 0, that's your origin. That lets you know that it's going through the origin. So let me take this information that I know, and I'm going to create an equation in this form, okay? So all proportional relationships equations are going to be in the form of y equals k times x. So here, if I wrote y equals k times x, my y stays my y. What's my k? Every time I multiply by 60, that's my constant. And then x. So this would be my equation for this table. My equation would be y is equal to k times x. Simple, easy. Once you know what you're multiplying times every time, that's your constant. Okay? That is your constant. And you can find that on your graph, on your table. You can find it from your equation. So now let's take a look at the graph. But I wanted to add a line here, letting you know that multiplicative relationships are always proportional. Okay? Multiplicative relationships are always proportional. Anytime it's multiplying or dividing, it's proportional. Hands down. Okay? Always. Never any other way. So here we're looking at a graph. It says the family road trip. On our x-axis, which is also independent. Remember, your x is the independent. It tells us the number of hours. On our y-axis, which is dependent, remember you depend on your parents, so the y depends on the x, we see the number of miles. So I can look at this graph and I see that at 1 hour, I drove 60 miles. At 2 hours, I drove 120. At 3 hours, I drove 180. 4, I drove 240. As you notice, this graph goes with the chart, right? With the table. So it matches. What you also notice is at 0 hours, I drove 0 miles. So that's the cool thing about multiplicative relationships. You can always think about, is this multiplication or division? Because if it's 0, 0, it's multiplicative. If I don't drive any hours, will I go any miles? No. So if you don't drive any hours, you're not going to go anywhere. So anytime you have an answer of 0, 0, you know it's multiplicative. If I don't pay for the ticket, will I have some? If I don't have no money, can I buy clothes? No. Like that would be a multiplicative relationship, because if I don't got it, it's going to be a 0, 0. Okay? So here, when we say it passes through the origin, if I was to extend this line past the graph, it would go through the origin. So goes through origin. Anything that's proportional will go through the origin. It always has to be 2 things. It has to be 1, a straight line, and go through the origin. It has to be both. It can't be a straight line and not go through the origin, and it can't go through the origin and not be a straight line. It has to be both. Goes through the origin and a straight line to be proportional. Okay? Also, what you can see from this graph is if I'm looking at 1 and 60, like I noticed showed you here, that will show me my unit rate. If I know in 1 hour I went 60 miles, that's my unit rate. That's my K, that's my constant. So we can get a lot of information from our graph, our table, to know if something's proportional. So this is the big picture, okay? Hope this helps. Let's go practice.